A little pinch of salt makes a large difference in taste and flavor. When the salt is missing from the table, we know its importance, otherwise, it remains unimportant. So, let's pay tribute to salt. So, our topic of today is salt. Myself, Deepak Patra, the guiding force, your friend, philosopher, will be taking you and teaching you salt. Here, we'll come across the various sources from where salts are obtained, the neutralization reaction through which salt is produced. Then I will introduce you to the various family of salt. You will be saying hello to them. Then we'll discuss types of salts, uses of salts, followed by a very important process, chloralkali process to produce the alkali sodium hydroxide, and chlor stands for chlorine. And last but not least is bleaching powder in our topic list. Let's first talk about salt. Salt is produced by the combination of acid and base. When acid and base combines, it produces salt and water. But before proceeding further, I would like you to have a recap of the previous knowledge of some metal ions and some non-metals also, along with their valencies. They will help us in a great way. Like if you want to win a war, we have to be well equipped. So these cation and anions, along with their valencies, are going to be very useful and play a very important role in understanding the concept of the various reactions involved, the various salts involved. So straight away, without wasting time, let's take some of the important metals iron, sodium, one of the most reactive. The valency is 1, potassium, the valency is 1. Then these are all cations carrying positive charge. The valence of sodium is 1, potassium is 1, calcium, the valency is 2, magnesium, the valency is 2, copper, the valency is 2. Along with, we can take zinc also, normally the valency is 2, and aluminium. Now it's a lot of metals we can include here, but these are some of the important metal ions which will play a very important role, and they will be an integral part of various family of salts. So these metals are very important, along with some non-metals. We should know chloride ion, the valence is 1, fluoride and bromide also, they have a valency of 1. Sulfate ion, from which sulfuric acid is formed, has a valency of 2. We have carbonate ion, the valency is 2. We have hydrogen carbonate, the valency is 1 here. Nitrate ion, NO3, valency is also 1. We can proceed further, but we'll limit ourselves to these anions. These are negatively charged ions and these are positively charged ions. The valencies, these are the valencies I have listed here for this. Now, as I have told you at the beginning, salts are produced by the combination of acid and base. So the parent acid and parent base from which a salt is formed plays a very important role. Now let's take a particular example, a very example of table salt, that is common salt, we call it as sodium chloride. As the name suggests, it is a cation part and an anion part. This cation part, sodium, is a metal and chlorine part is a non-metal. This chloride ion is contributed by the parent acid, and sodium ion, the positively charged ion here, metal ion, is contributed by the base. This is the key thing we should remember. Whenever I say chlorine, it should remind you of hydrochloric acid. Wherever you come across fluorine here as the anion part, you should remember that it is hydrogen fluoride is contributing the fluoride ion. Similarly, the bromide ion is contributed by HBr, hydrogen bromide. Similarly, sulfate ion actually belongs to sulfuric acid. The main source of carbonate ion is the acid H2CO3, carbonic acid. Similarly here, hydrogen carbonate ion, the parent acid is H2CO3. That means what? The carbonate as well as the hydrogen carbonate, their parent acids are H2CO3 and H2CO3. Carbonic acid common. Nitrate ions belong to HNO3, nitric acid. Whenever in salt, if some word like sulfate strikes, sulfate, sodium sulfate, magnesium sulfate, calcium sulfate, sulfate word strikes, correlate to sulfuric acid. That sulfate ion belongs to sulfuric acid. Similarly, carbonate ion, how you can recognize carbonate, carbonic acid. Chlorine, chloride ion basically belongs to hydrochloric acid. Very important, very important. If you see any Cl here, so here this Cl definitely is contributed by the acid part SCl, and sodium is being contributed by sodium hydroxide. This is the base. From the name only, you can guess the base from which the salt is obtained. Just you to add a prefix after sodium, like this is the metal, add the word hydroxide, that is the base. If you take here magnesium chloride, magnesium hydroxide is the base. If you take calcium chloride, calcium hydroxide is the base. If you take aluminium chloride, even then also aluminium hydroxide is the contributing base. You just have to add OH after the metal ion. That's a very simple trick. But before proceeding further, let me take a holistic look. Let's simplify what happens. We know acid plus base gives you salt and water. Our main focus is to obtain salt here. Now let's take a simple reaction. Hydrochloric acid combining with the base sodium hydroxide gives you the salt sodium chloride along with water is produced. How this NaCl is produced? Let me show you the mechanism here. The negative part of HCl is combining with the positive metal ion of this is the sodium hydroxide base. If you find across OH means it's definitely a base, and this is an acid, hydrochloric acid. Hydrochloric acid. I'm doing an overwriting, you should avoid it. Hydrochloric acid. Now the anion part of the acid combines with the positively charged metal ion of the base NaCl. They combine and form gives you sodium chloride. Along with this H and OH also combines gives you water. Let's take another reaction, another base. Let's take magnesium hydroxide. and sulfuric acid. Sulfuric acid. What do we obtain here? We obtain magnesium sulfate. Here the balancing part is 2. Then we get the magnesium will combine with the negative anion part of the acid. The positively charged metal ion of the base always combines with the negative anion, that is the anion part of the acid, sulfate ion. Here you get magnesium sulfate. This is the salt, but MgSO4 plus water. S2. Now here 2 and 2 4. We have to take 2. Yes. We could have ignored the this 2 is not required here. In that case, 2 plus 2 4 and 2. It would have been better if we would have S2 and S2. Fine. This is the balanced part. S2SO4 plus magnesium hydroxide gives you magnesium sulfate. This is the salt here. Now, this reaction of reducing salts like sodium chloride is a salt, magnesium sulfate is a salt. This reaction in which salt is produced along with water when acid and base combine, this is the acid, this is the base combines, is called as neutralization reaction. Now next I will introduce you to family of salt. First, what do you understand by family of salt? A group of salt belonging to a particular common ion is called as family of salt. For example, let me introduce you to a family of sodium salt. A family of sodium salt. Very easy. First, sodium chloride. Along with the sodium metal, add all of them, the negative part. Then you get the respective salt. Like sodium chloride, you can make sodium bromide, you can make sodium sulfate. Sodium, next is sulfate, is just write sulfate. The formula of sodium sulfate is Na2SO4. The formula here is sodium chloride. Next we can make sodium carbonate. Sodium carbonate is Na2CO3. We can write sodium hydrogen carbonate. It's NaHCO3. Sodium nitrate is another salt. NaNO3. What do we observe here? Sodium is common and only the anion parts are differing here. If you change the anion part here and keeping sodium common, we get the respective salt. Here, Na2SO4 means sodium has a valency of 2. If you check here, sodium has a valency of 2, but sulfate has a valency of 2, but sodium has a valency of 1 here. That's the reason sulfate 1, so they will interchange, crossing over valency method. So sodium has 1, so it will go to sulfate and the valency of 2 will be coming here, Na2SO4. Similarly, it will be extra careful about sodium carbonate, Na2CO3, NaSCO3. So a lot of things we can make here. Similarly, we can discuss about family of, let's take another family of say sulfate, family of sulfate salt. Sulfate has to be the anion part, definitely. So we can tell sodium sulfate, magnesium sulfate, copper sulfate, calcium sulfate, zinc sulfate. So these are belonging to this. So just write here sodium sulfate, then we write magnesium sulfate is common, sulfate, calcium sulfate, potassium sulfate, goes on. Here sulfate is the common thing. Sodium sulfate, the formula is, we know, Na2SO4. Magnesium sulfate is MgSO4. Calcium sulfate CaSO4. Potassium sulfate, the formula is K2SO4. From the name of the salt, sometimes the questions get twisted in the board exam. So they give the name of a salt and you have to guess what are the parent acid and the parent, base from which it is formed. For example, if the salt is magnesium sulfate, is the salt name, and parent acid and parent base from which it is made. Now you can guess here. Parent acid is definitely SO4. The negative ion is contributed by. So sulfate, I have told you, it's sulfuric acid. See how easy it is. If you come across sulfate, I told you at the beginning. So that's contributed by sulfuric acid. So the contributing sulfuric acid, the parent acid is sulfuric acid. Magnesium, the base is very easy. Just add OH after Mg. So it will become magnesium hydroxide. Now, if we have take any other salt, sodium nitrate, NaNO3. You can easily guess the metal name, just add hydroxide. It becomes a strong base, alkali rather, and nitrate belongs to nitric acid. NO3, just check here, belongs to nitric acid. So it's HNO3. So easy. You pick up any salt, you can easily go back and tell the parent acid name and the base from which that particular salt has been made. For your simplification, let me give another example of copper sulfate. As I told you, the metal part, just add OH, it becomes your base. So copper hydroxide, CuOH2, and sulfate obviously belongs to sulfuric acid, S2SO4. So just by observing the name, we can easily correlate, we can easily get into the conclusion of finding out the acid and bases. Next is types of salt. There are 3 types of salt: acidic salt, basic salt, and neutral salt. Acidic salt is formed from a strong acid and weak base. For example, strong acid, you can take HCl, and this is a strong acid and weak base. Ammonium hydroxide is a weak base. When you combine them, this NH4Cl come close and they will give you an acidic salt, ammonium chloride plus H2O. Very easy. The strong acid will be the dominating factor here, contributing for the more acidic nature of ammonium chloride. The pH value is less than 7 of ammonium chloride found here. Here weak base is ammonium hydroxide and strong acid is HCl. So we can know. Like we can go back again. As I told you, you have to just whatever is written at the beginning, you have to add OH, that is the base, and Cl. Obviously, look here, Cl is contributed by the anion part is contributed by the acid. You have to be very careful. Cl definitely hydrochloric acid. Similarly, if it could have been a NH4CO3 ammonium carbonate, in that case carbonic acid is the contributor, the corresponding acid, strong acid. So this was the example of your acidic salt. An example of basic salt. As the name suggests, here base is the strong. It is formed from strong base and weak acid. Strong base, sodium hydroxide, is the strongest with a pH of 14, and a weak acid you take, acetic acid, CH3COOH. When you combine them, then what happens? Sodium acetate is formed, CH3COO Na plus H2O. This is a basic salt. Sodium acetate is a basic salt. Neutral salt, obviously the common salt that is being produced here, not neutral salt. Neutral salt, for example, strong acid, it is formed from the combination of strong acid as well as strong base. When a strong acid and strong base combines, it gives you neutral salt. HCl, which a pH value of 0, the strongest acid, combines with sodium hydroxide, the strongest base. I have told you earlier, the pH range extends from 0 to 14. 7 is the neutral value here. So this is the most strongest base, alkali we call it, because it is readily dissolved in water, and HCl has a pH value of 0, the most acidic. So strong is a classic case of strongest acid and strongest base. It forms a neutral salt. The neutral salt is obviously NaCl plus H2O. Types of salts we covered. Very important uses of salts are there. Important rock. It is the starting raw material for obtaining various chemicals. These salts are used. A lot of the chemicals like the sodium hydroxide, then bleaching powder, baking soda. We obtain a whole lot of things from salt. So due to shortage of time, we'll cover up all the remaining topics in my next class. Till then, bye-bye, see ya, and have a wonderful time.